So in today's class I will explain Doppler effect in light. So you have studied Doppler effect in sound, that is in waves chapter in class 11, right? What the Doppler effect means, the apparent change in frequency due to the apparent change in frequency in sound due to the relative motion between the source and observer. So here also we will define same Doppler effect in light means we can define the apparent change in frequency due to relative motion between source and observer. Okay, this Doppler effect that is very useful in astronomy. So they use this Doppler effect of light to find the radial velocities of stars and galaxies. You know that the universe is still expanding. That means with respect to us, the galaxies are moving away. So, but the light emits, that will coming towards us, but with respect to us, the universe is expanding means all the galaxies are moving away from us. That means the source is moving away from us. Because of that, what happens? Due to the relative motion, the frequency will changes. So here, in Doppler effect of light, we will define redshift. Okay, and we will define blue shift. So redshift means what? If source is moving away from us, what happens? The frequency will increases or decreases. So definitely if the source of light is moving away from us means the frequency appears to be decrease, and you know the relation C is equals to nu lambda. So where nu is nothing but frequency of light, lambda is wavelength. As frequency decreases, definitely what happens means the wavelength will increases. So here what is meant by redshift? What is meant by redshift means when the source is moving away from us. Okay, write down. When the source is moving away from us, the frequency of light appears to decrease and the wavelength appears to increase. This apparent increment of wavelength in light is called redshift. Okay, why the name is given as a redshift means wavelength is increasing means you know that VIB-GIR. Okay, in this VIB-GIR, which is having more wavelength means red is having more wavelength. So wavelength is increasing means it is shifting towards red color. Okay, hence that shift is called as redshift. And one more shift we will define in Doppler effect, that called blue shift. Blue shift means what? When the source is moving towards an observer. When a source is moving towards an observer, the frequency appears to increase and the wavelength appears to decrease. This apparent decrement in wavelength is called as blue shift. That means source is moving towards the observer means definitely the frequency appears to be increased. Frequency increases means wavelength will decreases. That means which side it will shift? It will shift towards blue color light, isn't it? Okay. Hence the name is given as blue shift. Remember this concept. Okay, Doppler effect in light. It is useful to find the speed of galaxies or radial velocities of galaxies. It is used in astronomy. And a direct formula is given to find the radial velocity, that is change in frequency by original frequency. Here delta nu means what? Delta nu means change in frequency, and nu means its original frequency. Okay, change in frequency by original frequency is equals to minus V radial. Okay, minus V radial divided by C, where V radial is defined as component of source velocity, along line joining between the observer and source relative to observer. So the galaxy is moving away from us means definitely velocity means a vector. So we have to consider which component is acting towards observer. That component we have to consider. So that velocity is a radial velocity. So this formula is given. You have to remember this formula, and you can write it also. Change in frequency by original frequency is equals to V radial by C. That also you can consider it as change in wavelength by original wavelength. Remember, for this wavelength also you have to use negative sign, and radial velocity also negative sign. This is direct formula, no need to derive. And this is about Doppler effect in light. So based on this one problem I will explain. And also remember, write sign convention like what you have to consider means, if the radial velocity final answer comes positive means, okay, if positive, it comes positive means the source, that means the source is moving away from the observer. If it is negative means source is moving towards the observer. I will write here, write as a note. Okay, positive means here radial velocity positive indicates source is moving away. Positive indicates source is moving away from observer. And this negative sign indicates source is moving towards observer. Remember. Okay, based on that I will explain one problem based on the Doppler effect of light, that is in NCERT. See here, the question is, what speed should a galaxy move with respect to us, so that the sodium line at 589 nanometer is observed at 589.6 nanometer. Okay, that is its original wavelength is 589 nanometer, but the wavelength should appears to be at 589.6 nanometer. So to observe this wavelength, at what speed that galaxy should move? Definitely wavelength has to increase, frequency has to decrease, so definitely the source should move away from us, right? So what formula we have? That is V radial by C is equals to change in wavelength by original wavelength. That is here minus and minus will get cancelled. So here what is change in wavelength? This change in wavelength delta lambda 589.6 nanometer minus 589 nanometer means you will get 0.6 nanometer. This is change in wavelength. Then if you substitute here V radial is equals to this change in wavelength is 0.6 nanometer divided by 5, its original is 589 nanometer. Here this minus 9 also will get cancelled and multiplied with the speed of light, see 3 into 10 to the power 8 meter per second. So calculate this answer, that is V radial you will get, that is 3 into 6. I can write, if I shift one digit, then I can write 18 into 10 to the power 7 divided by 589. So if you calculate this answer, you will get 0.03056 into 10 to the power 7, or you can write this is nearly equal to, that means V radial will nearly equal to 305 or 306 kilometer per second. Okay, this is the answer. Finally we got positive sign, right? That indicates the galaxy is moving away from us. So I hope you understood this concept, Doppler effect in light. So after this concept, next I will explain one more important concept, one more important phenomena that is called as interference. Okay, a new concept that is called interference. So before understanding the definition or meaning of interference, first here you should know what is meant by principle of superposition. You have studied in waves chapter, principle of superposition of waves. If you have two waves in a medium, if we have a two waves, then they will superimpose at some point, two or more waves superimpose at some point in that medium. Then at this point, the resultant displacement, according to superposition, the resultant displacement of a particle or wave is this is the resultant displacement of a wave or particle means, so two or more wave means this is displacement of first wave and this is the displacement equation of second wave. Then according to principle of superposition, the resultant displacement at a point due to superimpose of two or more waves is vector sum of displacement produced by individual waves. Okay, this is what principle of superposition. So you have studied this statement in class 11, and two types of superimposition is there, that is one is constructive interference, and another one is constructive superposition, and another one is destructive superposition. So what is meant by this constructive superposition means, let us consider. So this is the first wave I am representing as y1, this is a crest, okay, and this is trough of the wave. So this is the displacement equation of first wave y1. Then let us consider another wave. So this is the another wave. Two waves are superimposing. This is first and second wave. Due to the superimposition of these two waves, we will get another wave, isn't it? So that wave means, that means here crest is crest upon crest, trough upon trough means that is nothing but constructive superimposition. According to principle of superposition is what? So two or more wave superimposed means the resultant wave will be y is equals to y1 plus y2. Suppose its amplitude may comes to be 1 unit and its amplitude may comes to be 2 unit, then the resultant wave amplitude will be 3 units, isn't it? In this way we will get this is the resultant wave of these two waves. This is y1, and if you consider this is y2, and this is the resultant wave, the displacement of resultant wave. This is what principle of superposition will states. So here intensity also increases, the resultant wave intensity also increases, and amplitude also increases. And destructive means, so how they will superimpose means, this is first wave, then another wave will superimpose like this. This is the second wave. Suppose this amplitude is 1 unit, this is 0.5 unit means we will get the resultant wave like this. This is the resultant wave of due to superimposition of two waves. This is first and this is second, and this is a resultant wave. So this is what destructive superposition. If two waves having same amplitude superimposing destructively means we won't get any resultant wave, okay, just a straight line. That means in constructive superposition the amplitude of the resultant wave will increases, intensity also increases. So in destructive superposition means the amplitude of the resultant wave will decreases and intensity also decreases. So this is according to principle of superposition. I hope you understood the concept of principle of superposition. And next, I will explain the phenomena of light that is called interference. So what is meant by interference here? First I will explain the condition when we will observe interference. That means to observe interference, this phenomena, the first condition is, so we should have two light waves. Okay, why? Because we are observing interference in light only, right? So hence we should have two light waves, and those two light waves should have same frequency. This is very, very important. Two waves will superimpose at some point. For the two waves, frequency should be same. And next condition is, what is the next condition? Means they should travel nearly same direction. So these are the two conditions to observe the interference. Should have same frequency and it should have travel nearly same direction. Then they have to superimpose. When they superimpose over one another, when they mix up, okay, then we observe the pattern that is called interference. So this is superposition of two waves, okay, that is the cause of this interference of light. So for that I explained that the constructive superposition and destructive superposition. I hope you understood these conditions. Then only we can observe interference. Then what is meant by interference? Means it is defined as modification of distribution of intensities, modification of distribution of intensity over a region of superposition, is called interference. That means for these two waves, okay, it is having intensity that is I1 and this intensity is I2, that will redistribute in a region. The modification of distribution, that means the intensity will redistribute over a region of superposition. For example, there are 10 students, each one having 1 rupee. So total how much amount? 10 rupees, isn't it? Then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 students. Then what I will do? I will collect 1 rupee from this student and I will give to next student. Then with this student, now the amount become 2 rupees. With this student, the amount become 0. And next I will do same. So 0 and 2. That means I am not adding amount here, or I am not taking amount from the student. Just what I am doing, I am redistributing this amount. Same, over a region there is intensity due to waves, but the intensity will redistribute. When they will redistribute means when they have same frequency when they are moving nearly same direction, then they superimpose, right? In that region, the intensity will redistribute. Intensity, that energy you are not adding there, and or energy you are not taking from there. So the intensity is redistributing. That phenomena is called as interference in light. So suppose these two waves superimposing here means, okay, if they obey this condition in the region, you will observe interference. What type you will observe means, you will observe somewhere a bright fringes and dark fringes. Okay, bright and dark fringes. Like this you will observe. Just an example, I said this is you will study in next classes. Okay, like that intensity will redistribute. Somewhere there will be a bright, somewhere there will be a dark, and you can say that the resultant intensity may be great. The resultant intensity somewhere it is more than sum of the intensities of light, or that resultant intensity somewhere it is less than resultant sum of that less than sum of the intensities of light. So this phenomena is called as interference of light. I hope you understood the meaning, the concept of interference. So here, to have a same frequency, okay, or so here you should know about sources also. There are two types of sources. One is a coherent source and another one is incoherent source. Okay, what is coherent? What is coherent source? Coherent source means it will produce waves, right? Okay, so the frequency will be same, and there will be no phase difference between the waves, or it will maintain a constant phase difference. That type of source is called as a coherent source. Incoherent source means the frequencies are random. That is called as a incoherent source. And to observe this interference pattern, we need a coherent sources. So next I will explain about that coherent and incoherent source, but remember, so the meaning, the definitions of coherent and incoherent. And next is I will explain the theory of interference. Theory of interference, or let us consider this is a analytical treatment for interference. So you know that this is the first wave and this is second wave. They are meeting at this point. At that point the resultant wave will form. That that displacement is let us take it as y. The equation I will write. You have studied in waves. So for the first wave, y1 is equals to a1 sine omega t. This is the displacement equation for first wave. And next, y2 is equals to a2 sine omega t plus phi. So where phi is what? Initial phase or phase difference between two waves. Then according to principle of superposition, the displacement of resultant wave y is equals to y1 plus y2. And remember, why we will have phase difference means the phase difference, it may be due to path difference. Okay, this wave may travel more distance, this wave may travel less distance. Because of that we will have phase difference, and it may start earlier, it may start later. There will be a time difference. Due to time difference also we will have phase difference. Okay, so this is the equation, displacement equation for first wave, and this is the equation for second wave. And according to principle of superposition, we have the resultant displacement is equals to displacement produced by individual waves. And this y is equals to y1 means I can able to write a1 sin omega t plus a2 sin omega t plus phi. So this y is equals to a1 sin omega t plus here a2 sin omega t plus phi. I will write as sin a cos b plus cos a sin b. In this way I will write. Okay, then y is equals to a1 sin omega t plus a2 sin omega t cos phi plus a2 cos omega t sin phi. Okay, and observe carefully here, y is equals to a1 or y I will take sin omega t common outside, then here sin omega t I will take common outside, then I can write a1 plus a2 cos phi plus a2 cos omega t sin phi. All mathematics steps only here. Then y I can able to write as so up to here. After writing, then what you have to consider means let us consider this a1 plus a2 cos phi as a cos theta. Okay, a1 plus a2 cos phi as a cos theta, and this a2 sin phi as a sin theta. Okay, so we are trying to obtain the equation for resultant wave. Okay, for that we are considering a1 a2 cos phi as a cos theta and a2 sin phi as a sin theta. So let us take, this is equation 2 and this is equation 1 and this is equation 3. So substitute equation 2 and 3 in equation 1. You will get y is equals to sin omega t a1 plus a2 cos phi as a cos theta. I can write a sin omega t cos theta plus a cos omega t sin theta. So if you take a common outside and if you observe carefully, sin a cos b plus cos a sin b, again I can able to write a into sin omega t plus theta. Okay, again in the form of sin a plus b. So this is the expression for displacement of a resultant wave, and where A is called what? This is the amplitude of the resultant wave, where A1 and A2 are, A1 is the amplitude of the first wave, A2 is the amplitude of the second wave. Okay, so this will also represents harmonic function, harmonic equation. Okay, how these two are harmonic equation by mathematical by analytical treatment we have solved, and finally we came to know this will also a harmonic function. Okay, so that is the final equation. Next what you have to do means, I will rub this side. Squaring and adding, squaring and adding equation 2 and 3. Then you will get in that right hand side, see here, a square cos square theta plus a square sin square theta should be equals to a1 plus a2 cos phi whole square plus a2 square sin square phi. So what I am doing, I am squaring and adding the equation 2 and 3. Then here cos square sin square theta plus cos square theta become 1 if you take a square common outside. So a square is equals to, if you split, a1 square plus a2 square plus a2 square cos square phi plus 2 a1 a2 cos phi in the a plus b whole square formula plus a2 square sin square phi. Then a square is equals to see here cos square phi sin square phi. A square if you take common outside, that will become 1. So a1 square plus a2 square plus 2a1 a2 cos phi, or capital A, this equals a1 square plus a2 square plus 2a1 a2 cos theta whole root. Okay, sorry, not cos theta here, a1 square plus a2 square cos phi, isn't it? So cos phi. So which expression this is means, to find the amplitude of the resultant wave, where a1 is amplitude of the first wave, a2 is amplitude of the second wave, they will superimpose. At that point you will get a resultant wave. That resultant wave amplitude is a. To find that value you have to apply this formula, like parallelogram law of vector addition similarly. And next one, after squaring and adding, next what you have to do means dividing equation 3 by 2. So then what you will get, a sin theta is equals to a2 sin phi divided by divided cos theta. This side you will get a1 plus a2 cos phi. So sin theta upon cos theta, here a will get cancelled, you will get a tan theta. Tan theta is equals to a2 sin phi divided by a1 plus a2 cos phi. So this is the formula to find the value of theta, this angle. That is the phase of the resultant wave. So how to understand with diagrammatically means, so this is a1 amplitude I am representing as vector, this is A1, amplitude of the first wave, and this is the second vector, that is amplitude of second wave, and the phase difference, that is A sin omega t in first equation, and in the second equation A2 sin omega t plus phi. So the phase difference between two waves, this phi is the angle between these two vectors. So then for these two vectors, this is what? Resultant vector. Okay, this is the resultant vector, that is capital A. So to find this amplitude of the resultant vector, you have to use this formula, root over a1 square plus a2 square plus 2a1 a2 cos phi. And what is this theta here? So final expression you got theta, right? That theta is this one, that is the resultant wave will make angle with a1 vector. To find this theta, we have to use this formula, and to find amplitude you have to use this formula. So mathematically we have derived. Okay, so this is useful to solve the problems, and this derivation also they may ask for 5 marks. So in the next class we will discuss the concept about constructive interference, what is constructive interference, destructive interference, and conditions. Thank you.